Okay, apologies for that. So I was just talking about I wanted to set the expectations straight for this class and what to come. And I also want you guys to evaluate yourself as you go along. From time to time, you're learning something new, you're practicing something. Always evaluate job description. Always look for work. Always go to job sites, find work, look at the job descriptions, and check where you are at the moment with that, just so that you can gauge yourself and the way in which you can expand on your confidence level is when you get to do more work. You get to do more hands-on projects. Obviously, you come to class like this, you listen to instructions and talk about theoretical things, and you're able to ask questions, and we can communicate on that area. But it has to go beyond that, which is the experiences that you acquire when you do things. So some of you guys are already in the externs program and some are curious about it. I always like to make the clarity so that you understand the differences between what you're doing here and there. So with the advanced class like this, obviously you have the projects on the portal where you follow instructions, you try to do things. Um, and in as much as that gives you some level of experience, there is still a gap. And the gap is not understanding the exact work related culture when it comes to working collaboratively within a team. So you get a job, you meet your team, they give you access to AWS, Git, and then you need to start collaborating, understanding how that collaboration work in a way that you wouldn't upset your team members or your tech leads or whoever is a very, very important skill to have, especially when you have a CV that claims you have a certain number of years of experience. You really want to get that out of the way before you get out there so that you don't find yourself in a messy situation. And I say this because I see a lot of people who sometimes graduate from our program, they go ahead, try to get a job. They eventually do get a job, but some of them do not pass the probation period. So some you get into an office that they do 3 months probation, 6 months probation, and a lot of people pass through, no doubt, but there is still that element for some people who do not scale through that period. And that's some of the things that this external program is solving. Being able to work with Scrum Masters, team members, tech leads, and being able to go through the Scrum ceremonies, sprint planning, retrospective, backlog grooming, and have learning sessions with tech leads as well to go through some very specific use cases. And you have access to a lot of use cases across different requirements. So enough said about that. Well, what I would like to do, so today's topic is on GitHub Actions. I was actually preparing for something else because I'm taking this class going forward for the first time. So I actually thought we'll be doing Terraform. So let me understand. Have you guys done Terraform in the course of all your learnings, or that's still ahead? Okay, Fini says I have not yet. Okay. So is that correct for the whole team? Like no one here. I mean, you may have Terraform knowledge. Some of you may have learned it on your own, but as part of the curriculum, have you done it? Okay, cool. Thanks, Festo. So you haven't done Terraform. All right. So today is for GitHub Actions. So what I will do is I will still take the GitHub Actions side of things. I'll try my best to make sure that it's still very, very valuable to you. Does anybody here have any kind of exposure or experience to GitHub Actions? Do you know what it is? Um, and you're very confident. In fact, if that's what we want to do today, you probably shouldn't be on this call because you know that much. Is there anyone like that here when it comes to GitHub Actions? Okay, I only have about 3 or 4 people interacting. We have over 20 people on this call, so it'd be nice for you guys to engage a bit more, so that it can help us not only finish on time, but also make the class a lot more fun. Please confirm
Yes.
if you can see. All right, thank you. Okay, so what we want to talk about today is GitHub Actions. And as you know, that in the world of DevOps, there are many tools. And I think it's one of the major problems that a lot of people face when they are trying to navigate their DevOps journey. Okay. The fact that you have a lot to deal with. You hear of Terraform, CloudFormation, AWS, Azure, Jenkins, GitHub, GitHub Actions, and it becomes overwhelming at some point when you can't really connect the dots. Okay, so what I'm going to try to do today is to help you to get a solid foundation on why we even need this tool called GitHub Actions in the whole mix of the different tools that we need to use. And then we go into a bit of the GitHub Actions itself and touch on YAML. Now, DevOps, again, I always like to make sure that I repeat this part in case you forget. DevOps is not a job title, okay, as a lot of people think. Even though now you hear things like DevOps engineer here and there. But when the concept of DevOps started, it wasn't about creating a job title for you to come in as an engineer that can be given that title DevOps engineer. DevOps actually started as a result of a problem, a huge problem that was prevalent in the tech industry when it comes to shipping products to users. And when we say shipping products, we're talking about packaging an application from the code. Because the way it works is developers will write code, whether in PHP, C Sharp, C++, Java, JavaScript, whatever language it is, the code they write is what becomes the product. Or the website, the Diary.io website, for example, there is some code that is running behind it that makes the LMS and dashboard and AI integration and all those things work. So, how quickly can we release features or how quickly can we fix bugs is going to be determined by the process running behind all of that. So the process, the people, the tools will determine how quickly we can respond to feature requests or bug fixes. All right. And traditionally, before DevOps became mainstream, we have dev teams and ops teams, and they all work in silos. And there's always this loggerhead going on between them because they all have different motivation that makes them do their work. Developers want to just keep on writing code. Operations want to keep on maintaining the infrastructure, supporting the code. And so when there is new feature request, developers are always quick to say, oh, okay, I know how to do that. I'm going to get on my laptop, develop a code that would do it. And they're excited about doing that. And they always want to see their products released and people using it. It makes them feel proud. The operation guys, on the other hand, who you can think like, Linux administrators, database administrators, network administrators, people who are supporting the infrastructure, their motivation is to have a secure, highly available infrastructure that will not make their pager duty or their alerts to ring in the middle of the night just because there's a bug or there's some problems with the system. So their motivation is to keep things running smoothly. So the problem occurs when the developers want to release something to the infrastructure and the operation guys always feel concerned because any new release is a potential risk to existing system because this new release may have some libraries that doesn't quite play well with the Linux kernel or some other existing libraries on the system that can just make things not to work. Or it can cause another system to not function properly just because you've released something on there. Now, obviously, the developer on his system probably doesn't have those existing things because he's just developing on his laptop. So he wouldn't face that when he's doing his development. But now we're talking about enterprise and production grade system, which is optimized to work and be available 24/7. So when you introduce any new thing to something that is working smoothly already, it is always there's always an iota of risk that gets introduced. And so operational guys are always pushing back to say, nope, you can't release this. Nope, it's going to take you 2 weeks. You're going to get to 4 weeks. You have to go back and test. You need to go to staging environment to test. You need to take it from there to a performance testing environment to test the performance of the system. You know, they just get them through all that. And I can tell you, I've lived during that phase when those things happen, and it's always chaos. Always, always. Meetings upon meetings and people complaining and you know, um, they're not happy. It's a big issue. And some organizations still operate that way, especially with legacy systems that cannot just easily integrate with the new agile way of working, you know? So what DevOps has come to do is to bring collaboration between the devs and the ops so that now it's no longer a case of, well, ops saying, we don't know what you're doing with your development work. We don't trust it. Okay, so for that reason, we can't take on the risk. It's no longer that because now they're both working together. The project is starting, they're both involved partially in the development, partially in the operation. So developers are now having understanding of how operations work. So when they're developing their code, they are interacting with the operations at the time of development, and everyone is collaborating. The same thing goes with the operation guys because now they're also able to put their infrastructure in the form of code, which wasn't possible before. Previously, you have data centers that you buy physical servers, all those sort of things. And developers don't have visibility into things like that. But now you can have Terraform that can build your entire infrastructure and is living inside Git. So that means you can have your infrastructure even as code, just the same way developers have their own code in a repository. So now you can also have infrastructure in a repository. So everyone has visibility into what's going on. The risk is completely reduced and, we have happy days. So part of the concept of DevOps is this CI/CD. Okay. So I've actually gone into the whole talk for today. But let me just quickly go over the course outline because we want to talk about GitHub Actions, introduction to CI/CD, which is what I'm about to start talking about. And then we'll get started with GitHub Actions. We do a bit of a demo implementing CI/CD, and then we'll talk about some best practices. Now, I think we have how many slides? About 25. So we may or may not be able to cover everything, but whatever the case is, we'll try and see how far we can go. So please, if you're distracted, I would highly advise, for you to just take all distractions away. Know that we're going to be here for a bit of time, maybe 2 hours plus, So it's always good when you have that expectations, you won't feel like you're overwhelmed. All right, cool. So we'll talk about the refresher. Okay, we haven't started talking about the GitHub basics, so we'll talk about that. But I want to do some introduction into the whole CI/CD thing because we're talking about it now. And DevOps comes with CI/CD as part of the concept that surround it, because DevOps is just a mindset shift in how things are done in the tech space. And it has some principles that when followed, then it shows that you are practicing DevOps. And so CI/CD is one of those principles, which means continuous integration and continuous delivery. And don't forget, each of those principles are driven by tools. So if you want to implement CI/CD, then you need a tool that can allow you to do that. So GitHub Actions is one of those tools that allow you to do it. And that's where the whole overwhelming thing about DevOps comes in because there are many tools that are out there that are able to do the same thing. you know. So even though GitHub Action is a CI/CD tool, there is Jenkins, there's GitLab CI, there's many other ones. Bitbucket, they have their own. There's Octopus. There's quite a few options out there. Okay, but what you need to focus your attention on is the most used ones in the market. That's how I learned technology. You can't go out there and try to learn everything. So some years ago, Jenkins was like the biggest in the market. It's like the number one. Okay. Now things are changing slightly. It's still big in the market because a lot of systems still rely on it. Okay. But things are shifting gradually. And GitHub Action is one of the ones that is taking a great momentum in the industry. Okay. So let's do a bit of refresher in terms of GitHub because we need to understand that there's difference between Git, GitHub, GitHub Action, so you know where they all fit into. Now, Git is a source code management tool. Okay, so Git in particular, so this we actually have to change this because GitHub, let me change this on the fly so that we don't confuse you guys. Because GitHub, on the other hand, so it's as simple as that. Okay, so think of it this way. Um, Git is a source code management tool. When you install Git on your terminal, on your laptop, you're able to use the command git commit, git push, git pull, git clone, git this or that, right? That is a source code management tool that allows us to collaborate as developers or DevOps engineers. Okay, forget about the web tool now, the web interface. Git itself doesn't have a web interface where you can go and see a repository and click to clone. Okay. It was developed by the same guy who developed the Linux operating system. Okay. Linus Torvalds. He's the guy who worked on this Git source code management tool. And the concept of Git itself it's not a new thing. So it's not like Linus Torvalds started it out of nowhere. So there were a few other options before Git. So there's SVN, and the architecture behind SVN is completely different from Git. So when Linus Torvalds introduced Git, it uses a decentralized architecture as opposed to SVN, which uses a centralized architecture, which means all the code is centralized on one server, and that's how you collaborate and work on it. But in the case of Git, it is decentralized because now, yes, there is a central server somewhere that we all contribute to, but I can clone a copy of your code. Howard can clone the same thing, and Adebayo can clone the same thing, and Isaiah, and all of us in this room right here, we can all clone the same thing. And if the central server goes down, okay, we still have copy of the repository. So in itself, it has disaster recovery built into it without building any infrastructure to support disaster recovery. So Git is that tool that allows for that collaborative element of working together on code. But then GitHub is the web interface that makes us to collaborate from the web using Git. Okay. So there are a few other concepts like repositories. So repositories are like containers for your project, storing code and related files. So if I go to GitHub, for example, you can see here we have repositories. And if I click on this, for example, you can see we have some code in here. Okay, we have some code. You can go into a code and see exactly what's going on, and everyone can collaborate and work on this. Okay, so this is what all right. So this is what makes the GitHub web interface possible. Because even though I can have my repository on my local and interact with it using Git commands, okay? But then I need the repository to be in a web interface where someone else can click and clone and work with. So repository is where we just store the code. Now commits is it represents the snapshot of changes made to the code base. So you're working on something, you just put a new change there. You can do git commit to say, here's a snapshot of my work so far before adding more and more code to it. And it helps us to roll back to a point in time if you need to, you know. And then we have the concept of branches, as you may know already. So it allows for parallel development and isolating of features, or bug fixes. So you have this repository right here, and let's say someone else wants to work on this, let's say Finn, for example. She can create her own feature branch and branch out from the main repository, the main branch where everyone is working. And then once she has her own feature branch, she can start working on it. Actually, I'm saying she, I'm not even sure if it's a she or he. In my head, that name sounds female already, so I apologize if I'm wrong. Okay, so I hope we know the some of this concept now. So do you guys have any questions so far? Okay, good. Good, good. I see a message. Fee. All right then. Any questions so far before we carry on? So the last one here says easily create branches for new features, and fixes. So yeah, that's fairly straightforward. All right then. So collaborating in GitHub. So it allows us to collaboratively work, which means now you can clone a repository, you can fork, you can do pull requests, create branches. It just allows all those collaborative work to happen. If we didn't have this, guess what will happen? You'll create a folder on your laptop, right? And as a developer, you work on it. You want someone else to work on the same code, you're probably going to zip it and then upload it to some place for another person to download. Now you have two different copies that do not understand each other at all. So Finny go ahead to work on her own version from the download. Now I have my own, the original one. Now Finny has done her work and she wants to merge it with mine. How do we do that? Unless she physically tells me, oh, Dari, I changed. Actually, let me go back to this. Except she tells me, oh, Dari, where I made my changes is go into this Argo CD file. You will find another folder in there called apps. There's another folder in there called Nginx app. Go to the basic dash app and then put this. And then she'll have to send me this code for me to add to mine. You can see how crazy that can be. That's just two developers working together or DevOps guys working together. Think of three, four, five, six, 10, hundreds. Because in an organization, you find hundreds of people working on the same repository. So it can be really, really crazy. So this is solving a huge problem. So CI/CD, we've talked about it, but briefly, let me talk about the fact that there is CI and there is CD. CI is continuous integration, and all it means is it ensures frequent integration of code changes into a shared repository. Because now you can see we have this repository which is now shared amongst us. Okay, we have direct pushing, we have well, there's no one pushing here right now. Actually, maybe I can go to our externs GitHub and you can see how we are collaborating there. So let's go to organization. Let's say pod B was the first pod, so there's a lot of collaboration going on there. And even though you can see I did a merge request, let's have a look at commits. You can see there are different people collaborating. We have Anthony collaborating, Oye Cloud, we have Isaiah, we have and Anthony, right? And then if you go to another repository, you can see, let's go to, let's say, pod A, and we can see that where are the commits? So we have a few people here as well committing to work. Let's go to another, let's see what they're doing there. Some commits. Okay, so they don't have a lot of work yet. But the point I'm trying to make here is continuous integration is when everyone is working and committing to the same shared repository consistently. And if you're on my webinar 2 or 3 days ago, when I was talking about Git and collaboration, you realize that one of the best practices is to constantly commit very, very often. So you're working, you resume work today, you put in your features, quickly you commit to a shared repository because other people are working too. So it's very important that you get your code and fixes up to date and push it to the main repository so that other people can pull it and see what's going on and put it into their own work. They can pull and put it into their own work and things can keep on going, very well. Then continuous deployment, on the other hand, it automates the deployment of code to production after passing CI. So CI is where we continuously deliver the code into a shared repository. And in that shared repository, that's where there is this pipeline concept. You can see, for example, this pipeline here has failed. Okay. Let me go to some of the previous pipelines. Let's go to actions. And let's go to, okay, this one passed right here. Only when things pass before it can move on to the next stage. So a commit happens in this repository. Let's have a look at the pipeline. Okay, it's been deleted because it's been quite a bit of time ago. Let's see what's going on here. I think these guys are more active. Let's have a look at their actions. Okay, so let's say, for example, you can see here, there is a pipeline, and that's what we're here to talk about. GitHub Actions, it has a pipeline that will help us determine whether what we are committing is passing or failing. If it passes, which means what you have committed to the shared repository, if it passes and becomes successful, okay, what then happens is it goes into the next phase of continuous deployment. Now, bear in mind, there is something also called continuous delivery. So let me just put in brackets, continuous delivery. So when you hear CI/CD, you see this CD part is actually two. So one is continuous deployment, the other is continuous delivery. Okay, and you can only practice one of them at a time. So you can have continuous deployment and continuous delivery happening, at the same time. So the moment continuous integration has been successful, the next thing is either continuous deployment or continuous delivery. Take note of this because this can be an interview question. Because imagine if you were asked, what are you practicing where you're working? Now, I can tell you for a fact, a lot of people practice continuous delivery. Okay. It is safer and less risky. Continuous deployment is mostly practiced by more mature teams that have their CI/CD process highly automated to the point where they are confident that the moment CI passes, it can automatically deploy to the production system. So that's why it says automate the deployment of code to production after passing CI. So that means the moment your CI passes, it just deploys the code to your production straight away. Now, guess what? The fact that something passes in your CI does not mean that once it deploys to production, things are going to work fine. Because it may pass CI from a code level perspective, but from a user experience, things may go wrong. Someone clicks a button, maybe it's slow. Okay, maybe it's slow. Now, the slow response is not the same thing as it's not working or it's erroring out. The error may have been captured on CI, but the slow response may not be captured. And if you deploy straight into production, then you find out that your customers start complaining and things are not working exactly how you expected. So what happens is to practice continuous deployment, there is a massive amount of automated testing that happens. So testing the code, testing the performance. So there are certain benchmarks that would have been put in place to say, okay, test that the response time is less than so microsecond. Different kind of tests can be put in place. So in the pipeline, they will have, they'll have all these tests. And as you can see in the diagram here, it says build test, acceptance test. There can be many other tests here, performance test, security test. And once that happens, it deploys to environment. So even though it says automatically deploys to production, there may be other environments in between, like the staging environment, but it happens in an automated fashion. The major difference between continuous deployment and continuous delivery is after it passes the test and the different things, it doesn't go straight to production. It sits there and waits until someone goes there physically and hit a button and say, okay, I'm happy, I've gone through it, I can see everything has passed, I'm okay, no concerns, click, and then it deploys to production. So that's the major difference between the two. Okay, so you can either practice continuous deployment or continuous delivery. Any questions? All right, so now let's talk about GitHub Actions. So GitHub Actions enables automated workflows directly within your GitHub repository. Unlike Jenkins, I'm glad you guys have done Jenkins already. With Jenkins, you have to install Jenkins, you have to configure it, you may even have to integrate other systems like LDAP, OAuth, so that authentication can be done automatically with using something like your Gmail or your Microsoft or whatever infrastructure your company is using. So many things can be done on Jenkins on its own, right? So it is not tightly coupled with your repository. You have to then connect Jenkins with your repository for them to work together. But with GitHub Actions, as you can see here, it is tightly coupled with your repository. So the moment you create a repository, like if I create a new repository now, let's go to repositories, and I create a new repository, let's call it advanced or for what month are we? This is June 2024. Okay. So let's say this is our new repository for a new project, make it public. Yeah, let's add a README, why not? Let's just put action script, README, license, whatever license, and let's just create something. Okay. The fact that we create a repository now that we can start working with instantly, we have the actions menu. We don't have to install any tool, nothing. It literally becomes available for us. And all we have to do is to clone this. So let me clone this. Okay, so you guys can, let me put it here. You guys can actually fork it. So you won't be able to clone this and push to it directly. I mean, even if you clone it, it's going to work. Like if I put this here right now, you can go to it and clone it. I mean, if you clone it, it's going to work, but you can't push to it. You can't push to it directly because it's inside our own organization. So what you need to do to contribute to this repository is you're going to have to fork it. So which means that you create a copy of this into your own account. So rather than it being in the Dart.io account, it's going to be in your own respective account. And then you can clone from there. So our advice, if you want to do tests as we're working right now, you clone it first, and then you go to the clone section, and then you can clone it. Now I'm using the SSH method because I have my SSH key configured on my laptop and the repository. That's why I'm using this. But if you use HTTPS, then obviously you need to use provide your username and password to push and authenticate. Okay. So what I'm gonna do is let me bring up my Visual Studio Code. Okay, let's see. So as you can see, I was actually preparing for Terraform today, but that's okay. Right, so git clone. So we have our repository. Now we've cloned this repository, we have it local, and we can start working with it directly. To have a pipeline for it, all we have to do is just create a directory structure that GitHub Actions will understand, and then it's able to work with it. So what I'm going to do now is, let me find my other notes where I can just put the sample code in there. Okay, and I think it expects to have a .github. Okay, and then inside a .github, you can have workflows directory. Okay, and then here you can have your workflow file. So let's say sample pipeline.yaml. Is anybody here familiar with YAML? Anybody here familiar with YAML? Or not familiar with YAML? Let me put it that way. If you're here and you're hearing YAML for the first time, you don't know what YAML is, which is this file type. Let me know in the comment section. Okay, so git status. Okay, we need to cd into the folder git status. So we've introduced this new GitHub folder. So git add, git commit, added GitHub pipeline. So GitHub actions pipeline and push. Okay, so let's see what happens. So if we, let's see if we picks it up. Not yet. Okay, so let me check. Maybe the naming convention is not correct. So I'm gonna actually, I can check from this existing repository and see what they have. Okay, so okay, there is no pipeline here. Oh no, there should be. Oh yeah, I remember it was removed. Let me check a different. All right, so it's .github and then workflows. Yep. Okay, so let's have a look. So we have the GitHub workflows and then that. Okay. So let's go back to this. Oh, it's picked it up now. It needed a bit of time. All right, so now you can see we have the pipeline currently running. And if we go to actions, we can see that we now have a workflow that's been added. So added GitHub Actions pipeline, and you can see our sample file there. But even though this has failed, what I'm trying to let you see here is the fact that we don't need to install anything. Just adding that file and the folder structure, we have a pipeline ready to go. Okay. All right. So we'll go through the file and understand what's going on there in a minute. But that's the point. So GitHub Actions enables automated workflows directly within GitHub repository. So it supports CI/CD, automation task, and more, fostering collaboration and efficiency. So the whole point here is that we're going to have automation. Okay. So anytime we have something pushed into our repository, there is automation that's going to trigger and run our build, run our test, and do our deployment. That's the focus. Now let's talk about a few concepts around the GitHub Actions. Any questions? Am I going too fast? Do I need to slow down? Let me know. And if you need to ask anything, just use the hand button, like I've just done, to raise your hand, okay? All right then. So GitHub Actions offers features such as continuous integration and deployment and automated workflows. It helps you to build, test, and deploy your code automatically, which we've seen. There's no more manual or time-consuming processes. And in the real world, people use GitHub Actions to check if their code works well together. So now we can collaborate and we can all trust. Let's say Festus pushes his code into the repository and it fails, we can easily see and we can all collaborate to have a look, okay, what went wrong? Why did it fail? And then maybe Shay can contribute and say, okay, oh, this is what you did wrong. And then Festus can go back and fix it and push it again and then runs again and then it passes. Okay. So let's have some definitions out of the way. So you heard things like workflow, action, steps, jobs. What are they? So a workflow is a defined set of automated processes executed on GitHub events. So you tell it the steps like checking code or making a release or whatever, and it follows your instruction. And that is an example of what we have in this file. So this file right here is our workflow. That's why you can see the name is called example workflow. You can give it whatever name you want. But everything going on in this file is our workflow. So it has the job section, which you can have multiple jobs. Okay, and then you can have steps, which are things that should happen inside this job. So if you need to have another, let me pull this a bit further. Okay. So if I wanted to have another job, I can duplicate this, have all of this, and say this is, let me call this build job, and then I call this deploy job. And it's not happy because I think it's indentation problem. So I'm going to do Shift Tab to take it about. Okay. So this doesn't need to check out anymore. We'll go through all these actions later on. Remove that too. Okay. Let's use this for now. Let's remove this part. I'm just going to use Apple here. Running tests. And let's see how this is going to behave. Okay, let's see what our job is going to pick up this time. And this time around, it's running the job, and what you're going to see, it's going to do an initial setup. So what happens is it needs to run on some server, okay, and it's using Docker behind the scenes, right? So that's why you have at the top here runs on Ubuntu. So it's running on in a Docker container that is Ubuntu. Okay, and we're gonna go over Docker later. But for now, think of it as it's running on a server that is an Ubuntu server. Okay, and then what it does is inside that Docker container, it checks out the repository. So because the Docker container is like a bare server that doesn't know anything. So what it's going to do is it will clone this repository, and that's why you have this checkout repository section. So it's going to clone it in there, and then it's going to start doing what we want it to do. So what, in this case, we want it to install Node.js. So assuming our application is a Node.js application, so we need a node to run on it so that we can run node commands to build the application. And then if we need to run some dependencies, it's just running npm install, which is a package manager for Node. And that's what it's doing right here. It runs that dependency step. And then the next thing, it runs some tests. So we just put an echo there to say running tests. So obviously, this is where If your team have automated testers, they all work as part of the whole team. So you have developers, testers, DevOps engineers, and your testers can write their test suite that will be part of this pipeline. Now, in some cases, the test can be what is called the unit test, which is a test written by the developers themselves. So for every function that they write in their code, they write a corresponding test to test each function. And what that does is it helps to ensure that every time a new feature is developed in the function, that feature is tested. So there is test logic put into the application. So whatever kind of test it is, that goes into this step, or you can even have different test step for your test. And if you are doing an automated deployment like continuous deployment that we discussed earlier on, then this is the part where everything before it passes, you just have your deployment step that just goes in and just deploys your work. And then let's say you want to notify people after that has happened, you can just notify people in your post step, or you could do your cleanup, which could be to delete the repository or remove some credentials that was used during the pipeline. Whatever it is, you can define everything in your pipeline. And the whole of this is a workflow. Okay, so this is an example of an entire workflow. An action is a single task within a workflow, like building or testing a code. Actually, let me see. Okay, so it's talking about an action. Now let me quickly show you something. Okay, because you can see here there is something called checkout repository as part of the steps, and it has this syntax uses and it's calling actions. And there's an action called checkout, which allows you to check out your repository onto the server. So let's talk about actions for a bit. See, these actions are things that someone else has developed. You could even develop it. It could be something that you write in JavaScript or shell script or anything. And GitHub, they have something called the marketplace. Um, how can we get there? Let me just go to Google. GitHub Marketplace. Okay, so if you go to Marketplace, so it just takes you to github.com/marketplace. And this is where you can search for actions that other people have done that you can just make use of. And it has categories. So actions on backup, chat, code quality, anything you want to do, it has different categories. Okay. But let me just search for the one that we're using here, which is to check out repository. Because if you don't, let me tell you what happens if you don't use an action like the checkout. You're going to have to put something like git clone command to clone your repository. But if you do that, you have to manage your credentials. How is the Ubuntu server that this pipeline is running? How is it going to know how to connect to your Git? If it needs to do any kind of, especially if the repository is a private repository, it comes with overhead. And this action right here is like a library that has solved all that problem. So you just specify actions checkout and it knows exactly what to do. And it's just going to ensure that it checks out your repository right there. So if you look at it and go into it, this is the checkout action. It has the description and it always tells you the latest version and you can select from the versions here. So the latest version is 4. These are just minor versions. We'll go into release management, to understand minor, major. Uh, this is called semantic versioning. So we're going to semantic versioning somewhere down the line. Okay, but just know for now, this is V4, which is the major version of it. So in this case, we're using V2, so you can change that to V4. It would know that it needs to use the version 4 of this checkout function. But if you read it, it tells you this action checks out your repository under GitHub Workspace. Now, this GitHub Workspace happens to be an inbuilt variable. So it happens to be an input variable that has a value. Okay. So the value itself uh, for this GitHub workspace is the workspace, which is if we're talking about workspace, talk about the name of this repo. So if this is the repo you're working on, your workspace is going to be the name of this repo itself, and that's like your folder. So it checks it out in there, so that your workflow can access it. Okay, that's bottom line of what it does. But there are many other parameters you can pass to it if you have custom SSH token, whatever. But without passing anything at all, it knows exactly what to do and it can just carry on like that. So there are many actions that you can use for different purposes, and it gives you examples, and you can literally just copy it and paste it. It's just like, imagine if this is the one you want to use, actually, let me use this one for example. Assuming I had created a particular branch and I wanted to check out from that branch, you know, it will, I can use something like this. And then the name of the branch, let's say I check out -b. I just create this branch, my branch, advance. That's the name of the branch I've just checked that into, and I can just copy that. Once I push the branch, because I have to push it for it to be able to access it, and then I can say with reference my branch. And it's able to know that, okay, this is the branch that I need to work with. Okay. I don't know why this, but it might work. So sometimes you can ignore the squizzly thing because that may be a YAML specific error. But as long as we copy this directly from the documentation itself, I'm sure you're fine with it. But you get the gist. So the gist here is you can access the functions to do whatever you want. Okay. So let's go back to our slides. So this is that's an example of an action. And don't forget there are many actions. If you're working with AWS, for example, if I go back to the marketplace and I'm looking for some action that I can use to work with AWS, there are many things, AWS Core Runner, whatever that does, policy checker. Let's go into this. Policy checks to validate AWS IAM policies in Terraform templates. So you can go through the documentation. If it fits into the requirement that you need in your pipeline, then you can just use it and you can see some examples of how to use it. And that's how to work with it. So that's how you will gradually build your pipeline depending on the use cases of things that you want to do. But on a very high level, most of the time, you just want to have a workflow that builds your application, that runs your test and deploys it. Of course, you may be working with Terraform or Ansible or Docker or different things. So depending on the technology you're working with at the time, then you will start thinking about, okay, what action can I go and find that I can use with it? All right. So now you've been seeing me work on this part of the paper. You're wondering, okay, what is this, YAML that we're talking about? How do I even know how it works? Okay. So what I'd like to do is just do a little bit of a crash course on YAML. Yeah, I did know you can go for it.
Right. Good evening. So I think what he wanted to say, because I actually wanted to ask the question, is the Git ignore and license. Are we meant to pick anything there when setting up the repository, or we just let it be?
Oh,
That's what he
okay.
wanted to say. Yeah.
Right. Okay. Okay. When I was creating the repository, right? Okay. Well, so let's go over it again. So it depends on what you want to do, but let's just go over it. So let's say we want to create a test repository here. And now README, best practice, yes. Make sure you have a README because a README is like the documentation for your code repository. So anything about your project is documented in this README. Okay. Now Git ignore is also very important depending on the project you're working on. Now, let's say that you're working on a Node.js project, okay? Node.js. And with the way Node.js works, when you're doing your npm install, it actually installs some libraries locally on your laptop that should not be pushed to your repository. So if there's anything that shouldn't be part of your code that is only required locally on your laptop, that's what a git ignore is there for. So I've talked about Node.js. Now let me see if there is. Okay, so there's something for Node. So depending on the project, in fact, if you're working with Terraform, you can see there's Terraform there. If you're working with, let's say, Docker, okay, there's nothing for Docker. Let's say Java, there's something for Java. So depending on what you're working with, when you're creating something fresh, you know what the project is going to be about. You know the technology that repository is going to support. So most of the templates here are already there for you. Previously, there wasn't this template. You have to think of what it is and just create a file called gitignore, and then you put in there whatever you want to put in there. But I'll show you examples of what goes in there now. Now, let's say we want to work with, let's say Terraform. Let me not use Node, just because you guys are going to be working with Terraform. I don't know, you've not done Terraform, right? Okay, but it's still okay. Now, license wise, again, depending, this is something that you probably don't really care much about, except you are the developer that you're starting your own project and you want to determine what license to use, especially if it is open source, if it's closed source. It's just about understanding the terms and conditions that other people need to be aware of before they can interact with your code. Some code, even though they are open source, you cannot reuse them for commercial purposes. And that's what these licenses document. So some license allow you to reuse an open source project for commercial purposes with certain conditions. Okay, so each of those licenses are different. So as a software developer or a company developing a project or whatnot, you know, you have to understand those licenses, know what it is, and if it fits into your purpose, you can use it. I think a lot of people use the MIT license, but if you really need to know more about it, you can just type in MIT license to understand, MIT license commercial use. So MIT license is one of the most permissive and allows for almost unrestricted use, including for commercial purposes. See, so if your project is based on MIT license, it means people can use it even for commercial purposes. But if it is, let's say, Apache, what does it say? Apache 2 license, because we saw that there. The Apache 2 license very clearly allows commercial use. The sole major difference between Apache 2 and, let's say, MIT is that Apache 2 prevents you from using, you can see that one has some caveats. See, Apache 2 prevents you from using the trademark of the entity that created the original software that you're modifying. Because open source projects is basically taking a project that is open source and then you can use it and then you can start commercializing it and change it and whatever. And that's exactly what Linus Torvald did to create Linux operating system. Okay, because he used existing project which is based on the Unix operating system, and then he modified it, right? So obviously the Unix system had some licenses that allowed him to do something like that. Anyway, so if we go back to the ignore part, if I create this repository now, you see an example of the file that gets created. So we have this git ignore there, and you see what it's trying to say is any file that has .terraform, do not include it when I'm doing my git add. And this is I think it was Anthony, one of our externs when he was working on some of his project, and he's used to doing git add dot. And I was warning him that stop using that, especially when you don't have the dot ignore. So when you do git add dot, it means you're adding everything to your code base. And it's possible that when you're running your Terraform or whatever tool you're using, they create some files locally. And those files that are created locally are used only for local use. It's not intended to be committed into the repository. In fact, in some cases, some of those files contain sensitive information that should never go to a public repository. So if you have like a secret file or whatever, if that secret file is called .secret, you can include it in this .ignore file to make sure that anytime you are doing git add, it ignores all these files that you're seeing here. Does that make sense? So that's why, it is not by fault, right? But once you know what it does, you can make your own decision as to whether to include git ignore or the license. Okay, Adebayo is asking a question.
Yeah, can you hear me?
Yes, I can hear you.
Yes, so I understand the fact that adding using the terminal. However, what if we're adding through the source control on VS Code? Because you're talking about adding the dot when you're using the terminal. Does it mean if you add using the source control on VS Code, does it add the dot to it or not? I just want to be sure.
Okay, so that's another thing. And I said this as well in one of my sessions yesterday, I think. And I was encouraging someone to not use your VS Code for your Git operations. It's it's okay for learning when you start learning and all that, but professionally, when you start doing things more and more, you want to avoid getting used to using your Visual Studio Code to click, to add, to commit, to push. No, no, no. Okay, if you've been doing that, that's good because you know it exists. But going forward, make sure you do not get used to, using your Visual Studio Code to do all the Git operations. The reason is because, first of all, Visual Studio Code is not a standard tool that every organization is bound to work with. You can get to an organization that does not even support it at all. So if you are used to clicking and doing things in your Visual Studio Code and you have no familiarity with you using your Git commands to do most of the operations, you're going to be stuck for some time before you get up to speed again. And it's not good when you're used to something. If you're used to your terminal to do all your operations, is a safe haven because whatever circumstance you find yourself, whether they accept the tool or not, you know that terminal is 101% supported and used. So you have nothing to fear with that. And you're used to it anyway. So your git commit, git clone, git rebase, merge, whatever, you're used to it, you understand it, and it makes life easy for you that way. But now to answer your question, I haven't used Visual Studio Code to create a new repository to even know whether it gives you the option for git ignore and all that. But I'm to a large extent certain that it won't give you that option to add git ignore because that functionality is something that GitHub provides. Okay, so it's only coming from GitHub database. They have their database of the templates for all the things that you added. And I don't think Visual Studio Code has a database like that locally to you, not to my knowledge. But I hope that answers the question. So most times, if you're creating your repository afresh from your local and you're the one initializing it from your local, then you will have to figure out the git ignore file. So this is the example. I think I selected, I can't even remember the one I selected for this one when I was cloning it. But this one for whatever I selected it for, whatever technology I selected it for, these are the files or folders that it's going to ignore. Okay, so that means the project I selected will create some executables, SWF, IPA, whatever, and then it can ignore them when you're doing your git add. So does that help? Okay.
Hi, Derek. Sorry.
Yes. Hi, Howard.
Hi. Just a quick one. So, if I'm getting you correctly, if I needed to create a new repo and also push my, but I already have the say files on my local machine. I would first need to create the repo and then clone it onto my machine, then start the file structure, rather than starting the file structure and then creating the repo and then pushing the file structure onto the repo. You get what I'm saying?
I don't
Should I
get,
start again?
but let me try and see if I understand. So what you're asking is it better to initialize your repository from terminal and then push to GitHub, or whether you go from GitHub and then clone it locally?
Yeah.
Is that
So
what?
what it is, for example, I'm working on a Terraform file
Mhm.
structure. I've created the Terraform file structure locally on my machine, but I haven't yet created the repo on in the GitHub.
Okay.
So would it be fair if I said what you're saying is create the repo first, clone it onto your machine, and then start the file structure, rather than starting the file structure,
Okay.
then create the repo and then
Okay.
push? Yeah.
So whichever one works. Okay. So if you already have the repo in, if you already have the file system locally, you don't have a repo yet, you can actually initialize that file system for a repo. Okay. So you just run the git init command and then it initializes it and then you push it. And, that is a bit harder than creating the repo, cloning it, and then put your code in there, because that one, it just works out of the box and you can just do your git commands and push and you're fine, you're good to go. Yeah,
Yeah, because
okay.
I'm like you said, I've been researching about the Git Gitno .gitno on VS
Ignore.
Code, and yeah,
Mhm.
and it doesn't give you that option of you
No,
will
it
have to do
won't.
it manually
You
and
have to do it
finding out
yourself. Yeah,
which files you want
exactly.
it to ignore. Yeah, thank you.
Exactly. Yeah, cool. All right then. So let's quickly talk about YAML, because you have to understand the structure of YAML to be able to work with GitHub Actions, because it understands only YAML. Okay, so YAML is a human readable data serialization format used for GitHub Actions workflow. So when you hear the word data serialization, what it means is, you see, GitHub Action behind the scenes is some software. Okay. The guys at GitHub have created a software that is capable of running all your workflows. So that software may have been written in Golang. I'm suspecting it was written in Go. And so that you don't have to write Go for your workflow, what you need is to provide a structure that can be serialized and passed on to the software running behind the scene, in this case, Golang. So it is a language that is declarative. As you can see, name GitHub Actions demo, run name this, on push, jobs that. It's a key value pair declarative language that serializes all the configuration, passes it onto the software running behind the scene, and then the software can interpret what you've passed to it and then take actions based on it. Okay, so that's what YAML is, and it's very, very basic, very simple. So let's just go through it so that you can understand from a high level. I think Leko has typed something. Let me just have a quick read. I think I found this method easy, but I'm afraid it's not the best practice. Create your repo and push your code seems easier than when you do it from local. Exactly. So that's what we've just talked about. Thank you. All right. So now to understand YAML, we need to know the key parts of workflow. So you have the job section, we have the steps, and we have the actions. So you have the jobs. Okay. So basically, even before the jobs, you have like what we call like the boilerplate, which is something that is standard for any workflow at all, which is the name and then the on condition, because you understand whether based on a push, this action should trigger, or based on a pull request, this action should trigger. And you can actually, let me see, GitHub reference, or GitHub Actions reference. So I'm sure there's a reference, yeah, GitHub workflow, Git workflow syntax for GitHub Actions. Okay, so all these parts of the workflow, they are all documented so that if you are not sure of certain elements, you can just go through the documentation. I'll send this to you. You can actually bookmark it and always make use of it. And this is the first time I'm even coming to this website. Okay. And how do I know that there's going to be a reference? I know that because every software that is mainstream, used by many people out there, they have a reference documentation for everything. There is always a reference documentation. Okay. So if you're picking up a new technology, you don't understand the syntax, don't worry. All you need to do is understand YAML. Okay. Specific to that technology, what to put in the YAML file is documented in some reference. So if you're working with Terraform, Docker, whatever, they all have their reference. Okay. So bear that in mind. Okay. So like the on section, you can see here it says to automatically trigger a workflow, use on to define which event can cause the workflow to run. For a list of available events, see this, and then they point you to this place. And these are the different events that you can use. So it says here on branch protection rule, types created, deleted. So if you have a branch that is protected, whether it's created or deleted, then run this workflow on that. Okay, so it has different one on check run. You can see the documentation on check run is documented here on check suite. And there's a pull request one too. Pull request. Let me see. Oh, I think it's called PR. Okay. There's a lot here, but if you start going through, you'll find it there. There's a lot of reference here, but I was just going to quickly highlight for pull requests. On public, this is like if the repository is public. So there is so many use cases that they have documented here, and you can just go through them. Okay, so back to our YAML to understand how YAML works. So you have all these elements. Now you know where to find them in the reference. So on this, name, that, run name. Now let's look at the key parts. So the jobs. So the job is a unit of work in a workflow. So this is our workflow, and the job is a unit of work in the workflow. For example, you might have a job to build a project and another to run tests. So you can have a job that does something and then have another job that does something. So under the job section, you have this explore GitHub Action. So this is one job. And under this job, you have this configuration to say, okay, run this job on this Ubuntu latest. And then these are the steps. And then you have step with the run command. Run, echo, run, do this, run, do that. Then this is another one. This part, you can see this one doesn't just have run because it's a step. Okay, I mean, they're all steps, but this is a step that is using actions, right? So you can see here, for this step, it has this name, and then it says uses. So if you want to use an existing action that's been developed, like the one I'll show you just now about the checkout action, this is where you now specify uses colon equals, well, not equal. So the colon there represents equals. That's key value. And they call it key value pairs. They're pairs of key and values. So the key here is it uses this action checker. Okay. And you have other steps, run, and then you have another step here. Now, this other step, you notice it has run, but it has name as well. So all of them can have name. Okay, you can choose not to give it a name. So all these ones do not have names, but this one has a name. If you don't want to give this one a name, you can just do hyphen uses straight away and it will still work. But this is an example of a run that has a name. So hyphen name, give it a name, and then you have the run, and then you tell it what you want it to run. So that is the fundamental structure of a GitHub Actions workflow file using YAML. And pretty much that is it, with GitHub Actions. So just to show you a bit, now these are things that we've been through in the demo, but it shows you what it would look like. You can have multiple jobs, and then they have their respective steps, and then you can see there's another job here that runs, which ultimately succeeds based on what happens previously. Okay. Implementing CI/CD action. So we've been through all this in the demo. So these are just slides. You guys can have access to these slides as well, just to really see what's going on. And that's it really on this GitHub Actions. There isn't anything else to do or learn on it. This is pretty much everything about GitHub Actions. What you now need is just use cases of how to work with it. So I believe there are projects on the Dare.io website where you can then use to practice things. But if you're part of the externs, there are many use cases there, that you can then have your mind a lot more exposed to the different use cases and how to work with GitHub Actions. So that's it. That's it for today's class. So if you have any questions, we can start taking them. Okay. Any questions? Victor?
Okay, sir. My question is actually about the capstone project on GitHub Actions and the advanced code platform.
Yes.
From the project, we were told to develop do a full stack application, e-commerce application, and use GitHub Action to automate it, and also do cloud deployment. That was the project. So I did it, then submitted. But the review is saying, I got a review, and he's saying that we're not told to do a full stack application. They were told to do a tech up.
Right. I
solution.
think I saw your comment on Slack, right? You did send a okay. Yeah, I saw your comment, and I took it with Ridwan, who's been working with the team, working with our AI integration, so that we can have a look at that. Because what we generally do is we tune our AI to evaluate the project based on the requirement. So it could be a case where there is I don't know, I have to look deep into it to know exactly what's going on, but it's part of on our to-do list for tomorrow when we come back to work tomorrow. So we'll get back to you on that, because I saw that comment on Slack.
Thank you.
Okay, and we have Shay as well.
Hello there. Can you hear me?
Hi. Yes, I can hear you.
Okay, so sequel to the question that was raised, regarding the project. So to what I understand, so as a DevOps, we're not programmers, so to develop stuff. So I'm thinking maybe there should be something like maybe like the source code being shared, and then we can walk through the source code, so I don't have to like bother my head about trying to maybe develop maybe the front end, maybe the back end.
Okay, is that for the Captain project you're referring to?
Yes. So I think the source code should be provided, and then we just do our own job rather than for me worrying my head.
Yeah, you're absolutely correct.
Develop the code.
That's true. You're right. I'll work with the team tomorrow on that, and we'll prioritize that and make that available. All right, cool. Yes, Extern is a different program. Actually, we have let me share the we just recently launched it. It's still beta at the moment, so we're building a lot of things behind it. I've sent the link. You guys can check it out. So there's a lot of people getting on the waiting list right now. And I think Howard is part of the extern. Howard, do you want to share a bit of your experience working, doing stuff on the extern side?
Yeah, so Daria has come up with some winners, but I think this is by far one of the best things that have come out of Daria.io. It basically introduces you to the real world, working world. I mean, it's studying and doing the capstones and everything on Daria.io. It doesn't prepare you as much as the extern prepares you, because you get to work with a lot of technologies and get to learn how to collaborate with others, and it's really good. I would encourage everybody to endeavor to get onto the program.
Thanks, Howard. And just to add to that, one of the things that makes that stand out is the fact that we are creating our own recruitment arm of the business, and we're partnering with companies, and we're creating what is called talent as a service. So what we're saying to companies is, we understand that you want to hire engineers, right? And you get all sort of CVs. And we've had people even from our program that does that, where they graduate, put certain experiences in their CVs, and then they go for interview and they get a job. But what we've also noticed is there's misalignment between the expectations of people hiring them and even the people doing the job, and then they struggle on the job and a lot of things happen, you know. So what we're saying to companies is, work with us. We have pool of talents that we have trained to a senior level, okay? And this is who they are. They don't have experience, 5 years, 10 years, or whatever. We have created this talent, built them up to where they are. These are the projects that they have worked on, and then they work with us to hire you guys. So it's like Diary.io as a company, deploying talent into organizations, startups, telecoms, whatnot, and then you get to do the work, build up more experience. I mean, that's like your employment. You're going to be on our payroll, and then we get the business going with the companies. So in essence, we're creating a solution where you don't have to work with the companies where the expectations are too high for you to handle. They understand exactly where you are, but also we are confident on the quality of the talent that we're putting out there. And it's one of the reasons why I've decided that I want to start taking these classes on my own, build you guys up, get you guys to a certain level that we are confident of the talent that we're pushing, to these organizations. So Exxon's, yes, indeed, it is paid. If you're interested, please reach out to the customer service, or whoever brought you into Diary.io, John, Ebenezer, or whoever it is. They will tell you about a lot more about the pricing, how it works, and all that. But essentially, it is not training, it is on the job experience, but it has learning elements to it, because we still have sessions where we go through your pull request, we go through the work that you've done, the tickets that you've worked on, you join sprint planning, daily stand-ups. So there's daily stand-ups, and that's exactly what happens in the real world. There's always daily stand-ups, backlog refinement, pair programming, all those things, and that's exactly what you're going to get there. Okay, so it's a different style or type of training. Okay, so what you're having right here is training, because we have live sessions and you watch videos and all that, but that is different. I mean, maybe I can even share my screen and show you some of the tickets that people are working on. Let me just share my screen and show you. Okay, so if I go to Jira, okay, so if I go to backlog, you can see these are the projects, and there's a huge list of backlog tasks that you get to work on. And we work in sprints. So this is sprint 1, and each sprint runs for 3 weeks. A sprint is a delivery of work. Okay, so the sprint goal for this particular sprint is to have an automated infrastructure and a good working knowledge of technology required to initialize Shally project. So the name of this project is called Shally, which is to have a secure and highly available login infrastructure. So the first part of things that the team is working on is to build the CI/CD pipelines with GitHub Actions, create Packer configuration to harden the AMIs. There's something called the CSI standards, CSI benchmark, which basically has certain tweaks to harden Linux servers. So there are lots of tweaks, and you get to pick up tickets, you get it assigned to yourself. So this is, for example, let me open this up. So this is an example of a ticket to work on. Let's assume you pick this up. It has description, it has acceptance criteria of what you need to work on. Okay. And then you get it assigned. So this is assigned to someone, and the description, this is exactly what it looks like when you join an organization and they give you a ticket to work on. So as a DevOps engineer, I want to update this script to configure time synchronization and secure kernel parameters based on CSI standards. The script must work on both Debian and Red Hat-based system. The Packer template should call the updated script and demonstrate a successful execution. So it has some acceptance criteria here, and there's an example code that has been provided that will guide you into the implementation of this task. So during sprint planning, we talk about the different work that we want to work on for the next 3 weeks. The first part of the 3 weeks is for you to pick up a ticket, and if there are certain knowledge gaps, then the first week is to learn and fix that knowledge gap. If you have videos you need to watch, crash courses you need to take, we have certain sessions from time to time. If you have questions, you have access to tech leads to guide you on things. And then once you are ready, you can pick up, start working on the ticket, and then you start putting your comments in there. So for example, let's see if, who is this? This person is working on this task, Samuel, and you can see they put their comments in there, and you have the admin responding. And this is exactly what is expected of you. You get to learn the culture. And once you get deployed into organizations that we work with, you understand the culture already. You're not struggling to understand and get up to speed. You can literally hit the ground running from day one. So that's what this solution is all about, in case you're not aware. And we've been trying to educate people on it for the last few weeks. That I think we launched about a month ago or so, and it's been fantastic so far. All right, then. Thank you very much, guys. It's been amazing on this call today. So let's meet up again. If there's any session that's going to happen during the week or so, I'll let you know. But let me work this week to know where we are and then decide how we're going to merge the two teams together so that we can take it from there. Okay? Enjoy the rest of the evening, guys, and we'll see you later.